First of all, you got to scale it the way I did. 1, 2, 3. That means you should really do what? You have to keep going, okay? Well, actually, you don't have to keep going because I said to do it at least 3. But here, -1, -2, -3. It shouldn't. Your 1 should not start here. How come? Because you have to go 2 boxes. I already started it. Every 2 boxes equals 1. So -1 should be 2 boxes later, 2 boxes later, 2 boxes later. And then, what are the points? Okay, when if you don't remember how to do it, just because I didn't make you do a chart doesn't mean you don't have to do a chart. Sometimes a chart is really helpful, right? So you could make yourself a chart, right? So you have x over here, and then you have y equals 2 to the x, okay? All right, 2 to the x. And so when I plug in 0, oops. Okay, when x equals 0, what is 2 to the 0? 2 to the 0 is 1. So I need to be at 0, 1. And then after that, what am I doing? Every time I'm multiplying by 2, right? 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So when I'm going backwards, what am I doing? Dividing by 2. So what's half of 1? Half. Right? Half of this. So why would you put your dot down here? No. Okay? It's half. You understand that half is right here, right? Half of 1 should be halfway. And then what's half of that? 0.25. So it's going half, and then half of that is here, and then half of that is here. You see that? So a lot of you guys, you made them go smaller, but you didn't do half and half and half. You guys just eyeballed it. Okay? But do you get that half idea? No? Okay. Oh, you're so smart. I understand what you're saying. I should just write it on the paper. I think I'm losing it, you guys. I really am. Yeah, 1 more week. Actually, next week, I'm going to turn my brain off. You guys are going to take finals, and I'm just going to relax. Okay, so I don't have until January to grade it. So don't worry about grading. Okay, so you're not even going to know your grade. You just do as much best as you can, and you'll find out your fate. That's how it is. That is scary, but either way. Okay, they think it's scary to not know your grade. But that's why you are in control of your grade. You don't need me to tell you your grade. You should know your grade because you study. Okay, yeah, you're right. You're right. Okay, let's not annotate anymore. How do I make this go away? Oh my goodness. Having technical difficulties here. How do I... Let mouse exit annotation mode. That's okay. Hello. Okay, fine. Anyway, do you guys see how... Okay, so if I were to... So I have -3, -2, -1, 0, 1, 2, 3, right? So 2 to the -3, 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. Okay, let's start with these. These are easier. What's 2 to the third power? 8. 2 to the second? 4. 2 to the first? 2 to the 0? What is 2 to the -1 power? I'm losing it. Okay, and then? What's 2 to the -1 power? What? That negative exponent makes it a reciprocal, right? 1/2. What's that? 1 over 2 squared, which is 1 over 4. What's that? 1 over 3 squared, which is 1 over 8. What do you notice about these numbers? 1/2, 1/4, 1/8. They're fractions. Which one's bigger, 1/2 or 1/4? How much bigger is it? It's double, right? So basically every time you're multiplying by what? 1/2, right? So of course, and that should work the whole way. What's half of 8? What's half of 4? Half of 2? What's half of 1? What's half of half? What's half of 1/4? It's like if you have a pizza and you split it in half, you have half of a pizza. But then your brother comes along and says, "Hey, give it me half." So then now you have a fourth of a pizza. And then you have your little fourth, and then your sister comes along and says, "Hey, share with me." So now you have an eighth of a pizza. Okay? By the way, I want you guys to see how this works with decimals. Okay? Decimal wise, what is 1/2 as a decimal? What's 1/4 as a decimal? Oh my gosh. What's 1/4 of a decimal? What's 1/8 as a decimal? You guys learned that at Stella. I know they made you memorize it. Yes, good, Jordan. And this should make sense. What's 1 as a decimal? What's 1 as a decimal? Okay, hey, there's too much talking. Let's think of it in terms of money. If I have $1 and I have to split it with you, how much do I give you? 50 cents. Half of 50 cents? 25. Half of 25 cents? 12.5 cents. Okay? So how does that look like on the graph? Okay, when I'm at 2, 2 to the first power is 2. But what's half of 2? 1. What's half of 1? 1/2. You know that because 0.5 is here, but also, look, there's 2 boxes. What's half of 2 boxes? 1 box. What's half of 1 box? Half a box. What's half of half a box?
But never touch.
Okay, so it never would touch. Why? That's why there's an asymptote here and there's an arrow. Okay? Yep. That makes sense, you guys? Alright, so I want to see, can we just, if some brave ones, those of you guys who had an error on this graph, can you guys show it to us so we can just see what are some typical errors that we see? Okay, so here's what Yumi did, okay? And don't laugh because you know you all did something similar. Okay, so he got a 5 out of 8. What is he missing? Arrows, so he missed the point for that. Okay, and if he made a chart, he would have known what's 2 to the first power. 2 to the first power is 2, so this dot. Yeah, so you got to pay attention to the scaling. And see, he left me to guess what that is. You know? I even put that line there. You're supposed to fill it in, man. Yes. Okay? And that's good for you too, because otherwise your eyeball, you're also kind of winging it. And what if it's wrong and this is a test and your life depends on it, right? Okay, what about here? What's 2 to the 0 power? And so 1 is not here. Even if you thought that was 1, you would have missed it. You would have still, because look, why is there all that space there? You guys see that? Even if he meant that, why is it not crossing the cross? Why is it up there? You see? And after that, he did the whole half business, but he started at the wrong place. So then, you know? See that? Thank you. Yeah. What do you mean simpler graphs? No. You guys need to know scale. This is very simple. Very simple. Yeah. I know. I did. I scaled it so that it would fill up the whole page. If I scaled it by 1, it would be really hard to get those decimals in there. That's why I did that. That's why I stretched it. Alright. Next one. Okay. This is the square root function. Okay. So, square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. And I gave you all this space on purpose so that you can say the square root of 25 is 5. Okay? You know, it doesn't hurt even to put in the points. It doesn't hurt one bit. It helps you and it helps me to know that you know it, and it helps you to make sure you did it right. Okay? Questions on that one? Yes? What is it?
I didn't have questions. What I did wrong is I didn't know I thought it was just that small on those, right? I didn't know how to extend it.
What smaller? Oh, this area right here? Yeah,
I was
but
confused. I thought we were only supposed to expand.
no, but look, why did I give you this arrow all the way to the end? And by the way, if it's blank like this, you always need to label your x-axis and y-axis, because your axes could be anything. It could be T and F. It could be Z. You know? One time I should trick you and put the y here and the x there. Just to see if you're paying attention.
I can't even look at that.
Okay. So be ready. Miss Han's gonna come back with a vengeance next semester. None of this Mickey Mouse business. Okay. Okay. All right. Okay. Now x cubed. Okay, now you have to really pay attention to the scale. Why did I make it grow by 2 on the y? 2, 4, 6, 8, 10. By the way, if after that you start saying 11, 12, 13, 14, 15, what's wrong with that? I was growing by 2 and all of a sudden you start growing by 1. Don't do that. But then the x is growing by 1 every 2 boxes. So you have to be careful. Yes?
Like, okay, so where are you supposed to grab the...
Right here.
Oh.
Both of these on the same.
And then you transform it?
Yeah, because it's easier if you see the transformation on the same. Yeah. Now, why do you think I scaled it like this? Why grow by 2? Because the function goes up really high. When you get to 3 cubed is 27. If I grew by 1, you will never get to 27. And I wanted you guys to see at least a good portion of the graph. So you had to realize that when you go over 1, what's 1 cubed? It's barely 1. So you have to go up half a box. Okay? And you guys, what do you notice about the x cubed graph? It should always be what? Yes, all in that shape. What else? It needs to be symmetrical about the origin. So if you go up 1 this way, then when you go back 1, you should go down that much. It shouldn't be like this one grew steep and this one's like flat. It should be symmetrical. Like if you flipped it around 180 degrees, it should still look the same. See? See that? Whether I flip it or not, it looks the same. Okay? When you go over 2 cubed is 8. 3 cubed is 27. Why would you make me guess when I have 90 papers to grade? Why don't you actually scale up? 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and so that's 27 right here, the middle one, right? And it should be symmetrical on the bottom. Now here's the tricky part. Some of you guys still don't know how to transform, but you still got it right because you made a chart and you plugged in values, and that worked for you. But let me tell you that transforming is actually quite easy. Okay? What would you do first? Okay, you know what I'm gonna do? What I really need right now is the small things in life make me so happy. Just the small things. Like that one kid wants to help me grade.
We're gonna help you during period 6.
No, but I really know this is so beautiful and thin too.
The way lower is
Okay. Ouch. Okay. So what do we... Ow, that hurt. Okay. Are you guys listening? Okay, let me wait. Everybody listen. What transformation happens first? According to PEMDAS, what would happen to the x first? You would subtract it by 1. So that happens first. What transformation is that? You were moving one to the right. And then what happens? The vertical shift happens next, right? Okay. Vertical shift happens next. Can you grab me one of the marker? Can you just grab me that box of markers, Genesis? Thank you. This is not working. It's not working out for me. Thank you, dear. Are you okay? On the tuba? Okay. All right. What about this 2? What does the 2 do?
Much better.
Is it?
No.
Get like a black.
That's a vertical, right?
You should buy the wedge.
Vertical stretch by 2. Right?
Yeah.
And then what is this? This is down 4. Okay? Alright. Alright. You get me? So let's do the shift first. Okay? So, well, actually, remember how we decided that the stretch, we like to do that first because it doesn't really matter, the stretch and the, like a vertical and horizontal move, you could do them independently. So let's do the stretch first. When I multiply 0 by 0, what do I get? Still 0. When I multiply 1 by 2, when I multiply 1 by 2, what do I get? 2. So it moved up. What about if I multiply 8 by 2? 16. Okay, that one's going to go too high. So you see how that moved here and that moved up, that moved up? So then this is also going to move down by 2. So instead of negative 8, it's going to be 12, 14, 16. Right?
Yeah.
Alright. So, what do we have here? We have this. Okay, do you guys see how the black one from the red, it shifted by 2?
Yeah.
Doesn't look that different, right? So look, this is now the same shape as this. The only thing I need to do from here now is what? Move it over by 1 and down 4. So let's take each point. This one, let's start with the middle. I'm going to move it over by 1. So now it goes here and down 4. But how much is 4? How many boxes is 4? 2. Because remember, these boxes are 2, 4, 6, 8. So it's going to move from here to there. You see that? What about this one? We're going to move it from here to over 1, down 4 to there. Oh, and this one. Over 1, down 4 to there. This one, over 1, down 4 to there. This one, over 1, down 4 to there. See that?
Yeah.
So now I'm here. That's my new graph. Okay?
And you said you want the coordinates?
No, you don't have to give me the coordinates as long as things are. That would be nice actually. I would be happy. But do you guys see what I did? I did first what? I stretched it and then I moved it over by 1 and 4. 1 to the right and 4 down. Okay? Let us actually do the coordinates. Yumi, what is this now? We move. It's 3 comma what?
12.
12. This one is what? 2 comma negative 2. The origin is, the center is what? 1 comma negative 4. Okay. This one is what? 0 comma negative 6. Okay. And this last one is negative 1 comma negative 20. Okay. Now let's see if we had made a chart. Okay, if I plug in negative 3, I'm going to get a really big number. So let's start with negative 1, okay? If I plug in negative 1, what would you get? 2 times negative x minus 1 cubed minus 4, which is what? What's negative 1 minus 1? Negative 2. Negative 2 cubed is? Negative 8. Negative 8 times 2 is? Negative 16. Negative 16 minus 4 is? 20. See that? If I plug in 0, okay, 0 minus 1 is? Negative 1. Negative 1 cubed is? Negative 1. Negative 1 times 2 is? Negative 2 minus 4 is? See that? You think the chart is easier? Okay. You could do that, but I want you to understand the transformations as well. You get the point? 1 minus 1 is 0. 0 minus 2 is Okay? Yeah? Okay. Ooh, I should have used this much sooner. Isn't this nice? Yeah. Okay. So, alright. Throw it back. So, did everybody get one of these? If you want to retake today, you need to show up at my door, line up and wait for me at my door by 4 o'clock with this finished. There will be no, oh, Miss Han, you were gone, so I left and came back. No, stay at the door. There should be no, Miss Han, you never told us that we were supposed to have this finished. Why do I have to work? I just want to retake. I just want you to grade stuff and do all the work, and I just want to do nothing except retake. No, none of that, okay? I only say that because it has been said in the last 24 hours. Okay. Okay. So make sure this is complete. Do you get those of you guys who started this yesterday? The answers are on the back. Yeah, I passed this. Remember, I told you guys to come after school to pick this up. Yeah. Does anybody have questions on this? Okay. So let us actually review for tomorrow's Radians. Okay. So I want you guys to get out the Radian sheet. Okay, that I passed out this morning. Everybody should have gotten one. By the way, the answer key for the this is on Schoology. Did you guys? How many of you raised your hand if you saw that on Schoology last night? That I posted that, the answer key. Just like 3 of you. I posted the pictures of this answer key last night on Schoology. This one. Yeah. You guys don't check Schoology, huh?
What time?
It was like 9 o'clock. Okay. Alright. Okay. Alright. Now, I want you guys to, if you guys want to have colors, you could get out some colors. Okay, markers or highlighters or what have you. Okay. Okay, now, this is what I think you should do. Remember what I talked about presumptuous? Don't be presumptuous that just because this makes sense to you right now that you know it. Because remember, I've explained this to you before, and I think you told me it made sense then, but obviously it didn't. So what I think is, what I think you guys should do is just watch me. Don't write this down right now. Just watch me, what I do, and then try to do it. I'll give you time after I'm done to do it. And try to do it on your own. After you're able, and then you'll struggle, and that time you'll ask questions and stuff, and you'll look at my answers and stuff, and that'll be fine. After that, try it again on your own sheet of paper and see if you could do it. And if you could do that 1 or 2 times on your own, then you can be a little presumptuous to think that you get it. Okay? But not until then. Does that make sense? Okay, so first watch me. Don't worry about writing anything down, just watch me. Unless you're one of those learners that you know you have to write, then go ahead. You know you best, okay? All right, so this is a unit circle. It's called a unit circle because this radius is 1. But that's...
1/5.
No, just 1. But that's not that relevant. Okay, now we're talking about angles, okay? The angles start here, so this is 0 degrees, right? It's also 0 radians. I decided that we set the radians such that, again, I want you to not write unless you really want to. Okay, the whole full circle is how many radians? If I go from here all the way around, it's 2 pi radians. Okay, so 0 and 2 are really in the same spot. Because if I'm here, it's 0. But if I open it up all the way and go all the way around, back again, then it's 2 pi. Okay? Now I'm going to split my circle in half. So instead of 2 pi, half of 2 pi is pi. Remember, that used to be called 180 degrees. But now we're calling it pi. I split it in half. Now let's split it in half again. So if this whole thing is a pi, then half of that would have been pi over 2. Right? And if this is 1/2 of a pi, and this is 2 pi over 2, then this is 3 pi over 2. Do you see why this is 3 pi over 2? Because it's how many halves? 1/2, 2 halves, 3 halves. By the way, 3 divided by 2 equals 1.5, right? And so it's 0.5 pi, 1 pi, 1.5 pi, if you like decimals. But we usually prefer fractions in higher math, unless we're doing a real world application. Okay, anyway, 3 pi over 2. You get it? Okay. So then, if this is 3 pi over 2, then this is 4 pi over 2. But 4 pi over 2 reduces to 2 pi. By the way, this is also 2 pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2. Okay, because what I set up here is write the radian measure for each special angle. These are special ones. I mean, this one is still an angle, and all these little ones, but there's certain special ones that we pay most attention to, so that's why we're working on those. But doesn't mean you can't have an angle down here, like really small, okay? But I want you to write in the most reduced form. These are the most reduced forms. But, however, you can still place next to it any equivalent forms. Like 2 pi over 2 is equivalent, so I put that there. But this is the most reduced form, okay? Now, I'm going to split the halves in half, okay? So if I have half a pi, and I cut that in half, that's this one, huh? And that's half of a half is a quarter. So that's pi over 4, right? So how many fourths is there? This is 1 pi over 4. That means this is 2 pi over 4, which reduces to pi over 2, right? So 2 pi over 4. See how many? I'm going a fourth of the way, and then another fourth. Which one will be the other fourth over here between these 3 lines? The middle one. So this is how many pi over 4s? 3 pi over 4. And then this one will be 4 pi over 4, but we already know that reduces to pi. Then I go over another 45 degrees, and it's 5 pi over 4. You see how I snuck in that degrees? And I go another pi over 4. What's that? 6 pi over 4. We're going by quarter pies. And then I go over here, it's 7 pi over 4. And what's this? 8 pi over 4, which reduces to 2 pi. Okay, because 8 divided by 4 is 2. Okay? Alright, I need a different color pen. Alright, let's do my blue. Now how should we cut the circle up? So here we can't just do halves. I mean, we could do eighths, but we're not going to go there. So let's go back to our 1 pi. This is 80 degrees is what 180 is 1 pi, right? I could split up that pi into fourths, which is what I did here. 1, 2, 3, 4. But I could also cut it into thirds. If I cut it into thirds, where would that take me? If this is a whole pi, right? If I cut it into 1/3, would it be this first dash or the last dash? The last one. And here, would it be the first one or the last dash? The first one. Can you guys see how I just cut this semicircle into 3 pieces? Equivalent pieces? So this piece is, that angle is the same as this angle, is the same as this angle. Yeah? So how many pieces did I cut this into? 3. So if this whole thing is a pi, this part is going to be pi divided by 3. You get me? So that's pi over 3. Okay? So if this is 1/3 pi, what's this? 2/3 pi, or 2 pi over 3. There's 2 1/3s there. Or it's 2/3 of a pi. Yeah? Then how much is this one? 3 pi over 3, which reduces to pi. Where's my next third going to be? The first tick? The second tick? The third tick. This one. Right? So this was 3 pi over 3, so this is 4 pi over 3. Okay? And then, is it going to be the first tick, second tick, or third tick? The third one over here? No, the first one. See? That one's going to be, this is 4 pi over 3. What's this one? 5 pi over 3. And then when I go all the way back here, how many thirds is it? 6. But 6 pi divided by 3 becomes 2 pi, right? Okay. Well, what can I do with my 1/3? Can I cut my 1/3 in half? If you split the 1/3 with a friend, how much of it do you have? A 6. If I take this yellow angle, right? Half of that yellow angle is just this part, right? So now this is a 1/6. So this is going to be pi over 6. So this little piece, every one of these is a pi over 6. So where's my next pi over? What's my next pi over 6? Yeah, you see how this is going to be pi over 3, 2 pi over 6? Because this is 1 pi over 6, this is 2 pi over 6. But that reduces to what? Pi over 3. So then where's my next pi over 6?
That next one.
Which is
3 pi over 6.
3 pi over 6, which reduces to 1/2 pi, right? Where's my next sixth? Right here. So this one is has the most common multiples, right? Or I don't know how to say it, but yeah. 4 pi over 6, which is reduces to 2/3, right? And then 5 pi over 6 is right here. And that one is already reduced. And then the next one is 6 pi over 6, which is 1 pi. So then the next one, 6 right here, is 7 pi over 6. The next 6 pi 6 over is 8 pi over 6, which reduces to 4/3 pi. The next one over is 9 pi over 6, which is 3 over 2. The next one is 10 pi over 6, which reduces to 5 over 3. The next one is 11 pi over 6. And the last one is 12 pi over 6, which reduces to 2 pi. And now we have our complete circle with every special angle labeled. Now this is going in the positive direction, but you should be able to go in the negative direction. And you know what else you should be able to do? What if I go more than 2 pi? Okay? By the way, yesterday I went to Daiso, the Japanese dollar store, and I bought all these little cute little sponge things. Anyway. Okay, so what if I asked you to find this angle that started here and went all the way there?
I don't understand that, to be honest.
Okay, so what that is, okay, is here's my angle, right? This is 0 degrees. This is pi over 6, pi over 4, pi over 3, pi over 2, and then how much is this? Pi. And I'm getting bigger and bigger. This is, and what if I went all the way back? I went a whole 360 or 2 pi. But what if I kept going after that? So that is a whole circle plus an extra pi over 6. You see that?
That'd be 2 pi over 6.
So that means I started here and I went all the way to here. You see? So what is that? This angle right here is going to be a whole 2 pi plus another pi over 6, which is 13 pi over 6. Because if we were only counting by pi over 6s, how many pi over 6s do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Remember, a full circle is 12 pi over 6. And then you went one more, so it's 13 pi over 6.
But you're already given 2 pi, not the 12 pi over 6.
I know, but this is gonna, but I need a common denominator. Think about that. Think about it that way. If I want to add them, I need that to have a common denominator, right? And so it's going to be 12 pi over 6 plus 1 pi over 6. Okay? But to me, it's easier if you just recognize, oh, all of that is 2 pi, which is 12 pi over 6. How many 6 is 12? 2 pi. 12 pi over 6, and then one more, right?
Yeah.
Now you also need to be able to go in the negative direction, guys. Okay? So what if I tell you to go from here to here? Okay? So I know this is 5 pi over 4 in the positive direction. If I had gone this way, it's 5 pi over 4, right? In the positive direction. But what if I went in the negative direction? Is it still, is it negative 5 pi over 4?
No.
No, how much did I go?
3 pi over 4.
It's the same thing as going up to here, right? But in the opposite direction. So it's negative 3 pi over 4. You see that? Before we do those more fancy problems, let's just take a look and try to notice what are some patterns. Let's just look at this. What are some patterns that you notice? This is 0, obviously, and how much is it up to here? Half. And then what do you notice about this? It starts, where do we start? What's the smallest angle? You start with the biggest number because you're dividing by 6 pieces. So it goes 6, 4, 3. Pi over 6, pi over 4, pi over 3, and then pi over 2. The smallest number is actually that gives you the biggest. The smallest number in the denominator gives you the biggest angle. Yeah? So this one, if you could kind of like have that locked in your memory, then you could start having more. What if I asked you to go all the way here? How can you quickly, without making the whole circle, realize where you are? Because you're going to look at this and you're going to notice this is what denominator? This is a sixth. But you know that a whole half circle gives you a pi, right? So how many sixths is that? So you know that you need 6 sixths to get to 1. And it's 1 more, so you know it's going to be 7. See that? See how that works? What if I asked you to get all the way to here? Oops. To here. What I would think is, hey, look, how many angles shy am I? That's a 6, isn't it? I'm a 6 pi away from being a full circle. How many 6 is a full circle? 12 pi over 6, and I'm 1 less, so I'm going to be at 11. You see? Okay, guys, I want you guys to, if you guys haven't filled out the circle already, try it on your own now. If you already filled it out, take out a sheet of paper and make your own from scratch with your own division marks and everything, okay? If you can do that twice on your own, then you know you got it. If you can't, then you don't have it yet, even if you understood everything I just said, okay? So fill this out on your own. You can look up here for reference. If you already did it, get out a sheet of paper and do it from scratch, okay? And if you mastered that, then you can try the other problems. Now this, I will not give this to you on the test. I'm not testing you on this. This is background knowledge you should already know. Although I should actually, maybe I'll give this to you guys as a test on next semester. Actually, I'll do that. But for this test, it's going to be the other stuff. The questions on the bottom, you'll have 2 of these, and then there'll be questions on the back. But you can't, it's going to be hard to do those if you don't know this.
If you can do that, you can do those.
If you practice extra though. Just because you're done with this doesn't mean don't presume that you're ready to do the other stuff until you practice. No, it's negative. So it's negative that. Okay, does everybody know what they're doing right now? Yeah. Anybody confused?
Does he have a blank bar or anything?
No, a blank white paper? You could get some out of my printer if you want. Or you need me to walk and get it for you? No, I'm not going to do that. And you guys, you know these problems on the bottom? It's going to be easy to do it if you have this unit circle in front of you, but can you do it without the unit circle in front of you? That's the test. Or can you make your own unit circle, which is what I'm asking you to do right now, to practice, right? Yeah?
Your first one is wrong.
You're right. Don't look at this, by the way.
Can I see what I have missing?
For what?
The homework.
Oh.
I think I have that done.
Need to make a circle.